Dear student, good morning all of you. Now today I am going to explain the problems based on fluid mechanics. Question first. A flat bottom test tube upright with 10 centimeter of its length immersed. The tube and lead salt were found to be 20 gram in weighted in a beam balance. The same test tube, when floated in kerosene oil, found to be float with 12 centimeter immersed. First, what mass of water does it displace when floated on water? Second, what is the area of cross-section of the tube? Third, calculate the relative density of kerosene. Solution of question. Solution. First, when the test tube is floating in water, the mass of water displaced by the principle of flotation should be equal to the mass of the test tube, that is 20 gram. Hence, the mass of water displaced equal to 20 gram. Second, let A be the area of cross section of the test tube. Then the volume of test tube immersed up to 10 centimeter of its length L is given by V1 equal to area of cross section into length equal to 100 equal to 10 square equal to 10 cubic cent equal to A into 10 cubic centimeter. A into 10 cubic centimeter.
cubic centimeter.
A equal to 10 cubic centimeter. By the principle of flotation, volume of water displaced equal to volume of the test tube immersed in water. Volume of water displaced equal to V2 equal to V1 or V2 equal to area of cross section into 10 centimeter. Mass of the test tube, mass of the tube with lead salt equal to 20 gram. Volume V2 equal to area of cross section into 10 equal to 20 cubic centimeter. Density of water equal to 1 gram per cubic centimeter. Therefore, V2 equal to 20 cubic centimeter. Therefore, 10 A equal to 20 or A equal to 20 by 10 equal to 2 square centimeter. Answer. Third, part third. When the tube is immersed in kerosene oil, is displaced 12 centimeter in it. Therefore, the volume of kerosene displaced by it is given by V3 equal to area of cross section into 12 equal to 24 cubic centimeter. Cubic centimeter. Let T be the density of kerosene oil. Therefore, mass of kerosene oil displaced is given by M equal to 24 into D into G. Now, Applying principle of rotation, 24 into d equal to 20 or d equal to 20 by 24 equal to 5 by 6 equal to 0.933 gram cubic centimeter. Therefore, relative density of kerosene oil equal to 0.833. Answer.
Bisa aku dah.
IIT target course 9, 11 and IIT JEE. Question 2. A body weighs 20 gram force in air, 18.2 gram force in a liquid and 18 gram force in water. Calculate first relative density of the body, second relative density of the liquid. Solution. And we know that in equilibrium, net force acting on the floating body is 0. 1 gram force equal to 989. Weight of body in air. Say W equal to 20 gram force. Weight of the body in water equal to 180 gram force. And weight of body in liquid. Say W2 equal to 18.2 gram force. First, relative density equal to weight of the body in air divided by weight of displaced water. This equal to 10. Part 2. Relative density equal to 0.9. Question 3. A small stone of mass M equal to 20 gram is held under water in a tall jar and allowed to fall as shown in the figure. The free body diagram of a stone is also shown. What do F2 and M1 represent? Question 3. Calculate the net force acting on the stone. Question. Repeat. Question 3. A small stone of mass N equal to 20 gram is held under water in a tall jar and allowed to fall as shown in the figure. The free body diagram of a stone is also shown. Calculate first what do F2 and M1 represented. What do F2 and M1 represent? Question 2. Part 2. Calculate the net force acting on the stone. Part 3. Calculate the acceleration as it falls through water. Take the volume of a stone at 80 cubic centimeter. Solution. First, F2 is the upthrust. F2 is the upthrust exerted on the stone by the water displaced by it. That is the stone, and M1 is the mass of water displaced by the stone. Second, net force acting on the stone equal to F1 minus F2, or F2 equal to M1G where M1 equal to mass of an equal volume of water displaced by a stone equal to 80 to 10 to the power minus 3 kg, F2 equal to 0.8 Newton, F1 equal to 2 Newton. Therefore rate force acting downward equal to F1 minus F2 equal to 1.2 Newton. Let A be the downward acceleration of the stone by using formula F equal to ma or A equal to F by m equal to 6 meter per second square. Answer. IIT target course standard 9, 11 and IIT JEE. Question 3. A wooden cylinder of 40 centimeter length and area of cross section 5 square centimeter floats in a liquid with density of 0.72 gram per cubic centimeter. Water is poured on the cylinder such that 4 centimeter of the cylinder is above water. Calculate part 1, the density of the wooden, and second, the mass of the wooden cylinder. Solution. Volume of wooden cylinder equal to 200 cubic centimeter. Let D be the density of cylinder. Therefore, mass of cylinder equal to 200 into D into G. Let H be the height of the cylinder above the liquid volume of the liquid displaced by this. Let H be the height of the cylinder above the liquid. Volume of liquid is placed by the cylinder equal to 5 of 40 minus h cubic centimeter. Therefore, mass of the liquid is placed equal to 5 into 0.72 of 40 minus h gram. By using principle of rotation, we have mass of liquid displaced equal to mass of cylinder, or 40 minus h into 5 into 0.72 equal to 200 into D, or 0.72 into 40 minus h equal to 40 D. When water is poured in the cylinder, 4 centimeter of the block is above water. Therefore, mass of water displaced equal to 5 of h minus 4 into 1, and mass of liquid displaced equal to 5 of 40 minus h into 0.72. Again, by principle of rotation, we have mass of liquid displaced plus mass of water displaced equal to mass of cylinder. Therefore, 5 of 40 minus h into 0.72 plus 5 of h minus 4 into 1 equal to 200 into D. After simplifying, h equal to 24 centimeter, or 40 minus 4 of 0.72 equal to 40 D, or D equal to 0.6, D equal to 0.468 gram per cubic centimeter. Therefore, mass of cylinder equal to 200 into D equal to 200 into 0.468 equal to 129.6 gram. Answer. IIT target course 9, 11 and IIT JEE. Question 5. Will the pressure exerted by water on a river at a certain depth in sea be the same or more or less than the pressure exerted on him in a river at the same depth? Justify your answer. Solution. As we know that density of sea water is greater than density of river water. In this case, upthrust by sea water will be more than river water. Therefore, a river will swim more easier than river water. Let the river be at a depth of h in seawater of density d1, d2 be the density of river water, and P be the atmospheric pressure acting on the surface of the sea and surface of the sea and river, respectively. Pressure P1 exerted on the river in seawater, pressure P1 exerted on the river in seawater is given by P1 equal to P plus H d1G. Similarly, pressure P2 exerted on the river in river water is given by P2 equal to P plus H d2G. Therefore, P1 minus P2 equal to Hg of d1 minus d2, or P1 equal to H of d1 minus d2 into G plus P2, or P1 equal to H of d1 minus d2 G plus P2. Here P1 greater than P2. Thus, the pressure on the river in seawater is more as compared to the pressure in river water at the same depth. Question 6. Atmospheric pressure is 10 to the power 5 Newton per square meter. At what depth below the surface of water surface of water will surface of water was here 10 to the power 5 Newton per. Atmospheric pressure is 10 to the power 5 Newton per square meter. At what depth below the surface of water will it become double? Solution. Let the depth be h. Therefore, pressure at depth h is given by P equal to 10 to the power 5 plus h dg, or 2 into 10 to the power 5 equal to 10 to the power 5 plus SDG, or 10 to the power 5 equal to SDG, or H equal to 10 to the power 5 divided by 10 to the power 3 into 9.8. This equal to 10.2 meter. Answer.